Good day, everyone. I wanted to give you a brief overview of the evolution of DCNM 11, which is now called the Nexus Dashboard Fabric Controller, or NDFC 12. The first point to notice is that now NDFC runs on the top of the common Nexus Dashboard platform. We have now a single pane of glass, which is the platform through which the end user can consume different applications for daily operations, such as the Insight application, the data broker, the orchestrator, as well as third-party applications. One of the key advantages for the operator with this evolution is that they have now this single experience. It doesn't really matter what application you run, from the installation process to the common web GUI. All applications and services look with the same logic behind any request. So from the Nexus Dashboard interface, you install your application of choice. In our case, we installed NDFC. So when you start the Fabric Controller service the first time, you are asked to enable the features you wish to use. In our case, we want to use the Fabric Controller to configure and operate our VXLAN EVPN fabrics. Hence, we want to enable the features Fabric Builder, Performance Monitoring, Endpoint Locators, etc. As we start from ground up, the first action we want to run is to create a new VXLAN EVPN fabric. From the navigation panel on the left-hand side, we select the Fabric tab. From there, we expand the actions to create a new fabric. We give a name, Fabric 1, and we choose the template. We need to choose the Easy Fabric template in order to deploy a VXLAN EVPN fabric using Nexus 9K or 3K. Now, the only parameters you need to specify, which is mandatory, is the AS number. So you can keep all the other parameters by default if you wish, or you can modify any of them. An example is to modify the IP range pool for the underlay. Now from the switch tab, you want to add the switch into the fabric. So you select the fabric of interest. Here we have only one, so Fabric 1. And you provide the seed units. You give the credentials. You specify the maximum hops between the seed units and all the other devices you want to discover, and you uncheck the preserve config because we want to start from ground up. So we want to erase the configuration if any configuration exists on the switches. You got a notification saying that you will erase the current configurations. So you confirm. So after a few seconds, you get the list of all devices discovered in these perimeters. You select the switches and you add the switches in your fabric. Now you can go to the topology. You can go inside the Fabric 1, and now you see the topology with the 2 spine and the 4 leaf nodes. The role of the spine was given automatically. Now what we want to do is to modify the role for 2 leaf nodes into border gateways, which will be the devices used to connect the remote site. This notification to alarm you that you will need to recalculate the configurations of the fabric, and you recalculate the configurations. Now you see all the lines that will be pushed toward each devices. So this is for ground up. That's the reason why you have many lines. I just accelerate the deployment. It takes 1 or 2 minutes. So we want now to configure the VPC pairing. So we select the device. NDFC provides the recommended VPC peer device. So you just need to select the one connected with the same role. We save, and it's done. We do the same thing for the border gateways, VPC border gateways. It's done. Okay. And now we recalculate the configurations because we want to configure the VPC pairing, and we push the configurations. Now we want to add the VPC interfaces into the VPC domains. So we go now to the detailed view, we select the interfaces, we call the actions to create the interface. So we select the type of interface we want, so VPC. We select the VPC paired device. We specify the VPC ID, 17 for the first dual attach host. We specify VPC ID 18 for the next host. We specify 19 for the third host. We save. Now we can play with the filters. For example, we look for the interfaces that contain the VPC, the 3 VPC we just created. We recalculate the configurations. And now we can push the configuration, the VPC interfaces toward the fabric and the switches. So now we deploy the second fabric number 2. So this is very similar to the fabric 1, except the seed unit would be different. So we give the name fabric 2. We select the easy fabric template. We specify the IS number. Again, I'm going to change the IP address pools for the second fabric. Again, this is an option. You don't have to do that, right? Now you need to add the switch into your fabric number 2. So same as we did for the fabric 1. So you specify the seed unit, you specify the credentials, you uncheck the preserve configuration, you confirm, and you start the discovery process. You discover the 5 devices and you import the 5 devices into your fabric number 2. Now you see we have the 2 fabrics, fabric 1 and fabric 2, and as you can see, NDFC has already detected the links between the 2 fabrics. So you can go to the detailed view. Now you change the role of the fabric 1 and 2 to border gateways, the devices that will connect the fabric 1. And you can switch from one fabric to another very quickly. One of the added value with the new version of NDFC allows you to check what are the protocol states running on the topology. For example, if you are running a VXLAN VPN fabric, you can enable the show logical links to display all logical links and see if your underlay interface is up or down, what is the state of the different protocols running between your spine and leaf, such as OSPF or ISIS or BGP, the VPC keep alive, and what is the health of the protocols. Now let's deploy the multi-site domain. So we have the 2 fabrics. From the fabric tab on the left hand side, go to action to create a new fabric. Now we call it MSD, like multi-site domain, and for the fabric template we select the MSD fabric template. So what we want to do now is to automate the deployment of the multi-site. So for the overlay, we change the overlay to direct to border gateway, which is the back-to-back configurations, and we enable the underlay auto configurations. Right. Again, optionally, you can change the loopback IP range, and you save. Right. Now you go to the topology and you have your fabric MSD. You can click on the MSD, and now you go to the detailed view. And from the detailed view, you select the tab child fabrics in order to add now or to move the fabric into your MSD fabric. So fabric 1, and move the fabric 2. So now we have the two fabrics that will be part of our multi-site domain. So it takes a couple of seconds. You can preview the configurations, and you can retrieve the BGP configuration with the new neighbors, the border gateways, the loopback address 100 for the multi-site, as well as the inter-fabric connectivity using the interface 1/20, which is auto-populated with the IP address consumed from the NDFC pools. So it takes a few seconds to deploy the configurations towards the switches, and we can close this window. You can move the topology like you used to do with DCNM. So this is very similar. Now we want to create the interface grouping. Interface grouping is very useful when you have many leaf nodes with many interfaces that share the same networks across, the whole fabric. So we select fabric 2. From there we go to detail view. We select the interface group. We create a new interface group. We give a name. So basically we want to attach to this group all the web and applications for tenant 1, for example. I need to select all the interfaces 17, 18, and 19 that we will use for the interface grouping. So now I use the filter to retrieve all my interfaces of interest. I select all the interfaces 17, 18, and 19 from both leaf 3 and leaf 4. I go to actions, and from actions I add the interface to an interface group, the same I just created, and I do a save. As a result, in the fabric 1 we have 3 hosts dual attached to leaf 1 and 2, and in the fabric 2 we have collected interfaces from 6 hosts attached to leaf 3 and 4 to a group of interfaces named web app tenant 1. The next step is to allow layer 2 and layer 3 communication between virtual machines blue and virtual machines red inside the fabric 1 and across the multi-site domain. Let's go and configure the networks and VRF. So we select the MSD fabric. We go to actions. We select the detail view. From there we go to the network. It's empty. So we create a new network. We give a name. So we call it the web for tenant 1. We don't have any tenant, so we need to create our tenant 1. So we just give a name, and that's it. The rest is done automatically. And we return to our network, and we specify the VLAN ID. So we can get the VLAN from NDFC if we want, but I want to use a specific VLAN which is already defined in my POC groups. I provide the default gateway. And that's it. My network is created with my VRF. I do another one for my application, so I give the name. The tenant is already created, and same thing, I provide my VLAN ID and my default gateway. Create. And I repeat this 2 times for 2 other networks for tenant 2. If we look at the reachability between the different nodes, this is expected. We don't have any communications because we have created the networks and VRF, but they are not attached to any devices. For your information, the 2 bottom windows represent the layer 2 and layer 3 communication inside the fabric 1, and the 2 windows on the top display the layer 2 and layer 3 communication across the 2 fabrics. So now we want to attach the networks to the different devices. So we select here the network. On the network we can see the 4 networks we have created. So we select one of the network. right? And now with this network, we select the device where we want to attach this network, as well as the interface, if you remember, port channel 17, 18, 19, and we do a save. We repeat the same actions for the other networks. And we do this for all the networks. So now we can deploy the configurations. As you can see, VLANs have been added to the trunk for each port channels. And we deploy. Okay, now it's green. So if we return to our test, we can see that inside the Fabric 1, we have layer 2 and layer 3 communications working between the different nodes. At any time, you can check if and where a network is deployed. Green means that the network is attached somewhere. Click on the network of interest. This view displays where the network web tenant 1 is attached to. We return to the MSD, and from MSD we go to the Fabric 2. From the Fabric 2 we go to the detailed view, and now from the network we select two networks, and from the actions we add the networks into our interface group. Now we deploy the configuration. As you can see, we have the VLAN 2100 and 21.1. We deploy. Now you can check from each network where they have been deployed with the color green. So back to MSD, we go to the detailed view, and from there we select the network. We go to the network attachment, because now we need to attach the network to the border gateways. Select all the border gateways, do an actions, and do a quick attach. And now you deploy the configuration. So now we have the network deployed on the Fabric 1, network deployed on the Fabric 2, and network deployed across the two fabrics through the border gateways. We can see now that the traffic across the two sites, layer 2 and layer 3 communication is working. So from the MSD topology view, we can retrieve for each network how they have been attached. To enable the endpoint locator, we need the Fabric controller to communicate with the route reflectors using the in-band management. To achieve this, we need to create an SVI for the data interface VLAN on the virtual port channels attaching the Nexus dashboard. We will use a custom policy template to create the HSRP VIP for this SVI. So we need to configure the HSRP SVI for the VLAN 33 to allow the data interface of the Fabric controller to communicate to the default VRF via the in-band management. We have currently two options. Either we use the freeform config template, meaning CLI, or we can create our own custom policy template as shown now. From the Operation tab, open the template windows and select Import. Select the custom policy template built to gather the HSRP parameters. Check the properties and go to Next. This is a basic custom template I just built with almost all the variables required to enable HSRP for a particular interface we will use for the port channel 17. back to the list of policy templates. You can use the filter to retrieve the one we just imported. Now we need to select the fabric one, then go to detailed view, select the policy tab, add a policy, select the switch where you wish to add the custom template, and to start with we select leaf 1, choose the template, fill up now all the parameters as requested step by step. So VLAN ID 33, the physical IP address, the VIP, the network mask length, the HSRP group 33, the priority, and a slide descriptions. Now you can save, you repeat the same configuration for leaf 2. With as difference the physical IP address and the priority. And then you deploy the configuration. So you can preview the configuration for leaf 2. As you can see, the IP address used, the physical IP address used is 252. And you can do the same for leaf 1, 251. You can close and you can deploy. So you can double click directly on the leaf node to go further at the lower level where you can see how the leaf node is connected to. You can go to the detailed view, select the interface tab, and from there you can retrieve your VPC. So you select the VPC 17 where the Nexus dashboard is connected to. You can edit. And here we want to add the VLAN 33, right? The reason I'm adding this manually is because it's not part of the VXLAN fabric. So I can preview the configuration and I deploy. When done, so I go to my Nexus dashboard and I try to ping my default gateway, my SVI. Okay, and it's working. The network communication with the in-band management of the fabric being established in order to communicate with the default VRF, we can now deploy the endpoint locator. To achieve this deployment, we select Fabric 1 and from the scrolling action menu, we select Configure Endpoint Locator, which triggers the EPL wizard. We select Configure My Fabric. We select the spine devices proposed by NDFC as route reflector. We can preview what will be deployed automatically toward the route reflectors, and we save the configuration to activate the endpoint locator. So now EPL is enabled. It will take some minutes to collect the information for all the endpoints in Fabric 1. And to view the endpoints, we go to the dashboard and we can select the endpoint locator tab. And as you can see, we have one VRF. We have 6 endpoints attached to the fabric. We can select any of the endpoint to get more details. We can look at the endpoint life, which is here quite new, but basically it tells you the historic health of the nodes, if it has been disconnected for a certain period of time, or if it moved from one leaf node to another leaf node, and when this happens, etc. And now we want to visualize our VMs, our vCenters. So we go to the virtual management and we select the virtual infrastructure manager. We don't have any vCenter yet, so we go to actions, add a vCenter. We select the type of instance. We provide the IP address of the vCenter as well as the credentials, and it's done. Now we can go to the dashboard and we can see from the vCenter tab all the VMs discovered that you can visualize. Or you can visualize the VM directly from the topology view by entering into the vCenter. As you can see, and as of now, there are 6 physical compute nodes and 46 virtual machines. Let's have a look at the VM. You can view all the virtual machines that exist in Fabric 1 at once. You can click on one VM. You can retrieve to which DVS the VM is connected to, then to which ESXi host the DVS belongs to, and how the host on its turn is dual attached to the upstream leaf nodes. You can return to the vCenter and select one physical ESXi host, for example 149, and it shows you which VMs belong to a particular host via which DVS. You can expand the view for further details of the VM, such as the VLAN ID or which physical interface it uses. You can get the connectivity details from the DVS area as well. Let's return to the data center. Thank you for watching.